Hello AP Stats. This will be the Chapter 1 Exploring Data review for the AP exam. If you could have your review binder out in front of you, open to Chapter 1. It is titled Exploring Data. So what I tried to do in these reviews is to go back to each one of the chapters individually and to give the big picture of that chapter. So I'm not so interested in all of the picky tiny little details from each chapter, but more what are the big ideas that you need to take away from this chapter. So we're going to go through those here for Chapter 1. So the first thing that you have to be able to differentiate is the difference between a categorical variable and a quantitative variable. And this was actually part of your summer homework. And you can see here the definition for categorical says that it records which group or category an individual belongs to. And I just want to give you a couple examples of that. Gender would definitely be a categorical variable. Grade in high school, freshmen, sophomore, junior, seniors, that would be categorical. When we did the Skittles activity, we looked at the color of the Skittles. So the Skittle colors was definitely a categorical variable. Now if we look at quantitative, a quantitative variable has to be able to take a numerical value. So we definitely use GPA quite a bit at the end of the course, as well as ACT scores. Those are numerical or quantitative variables. Age, height, those are all examples of quantitative variables. So very important big idea in Chapter 1 is this next question. When asked to describe a distribution, maybe I should have you underline that word describe. This is very common to see on the AP exam. Very often question number 1 on the free response will ask you to either describe a distribution or compare two distributions. And of course, this is where you want to remember SOCs. So that's going to be your shape, your outliers, your center, and your spread. So you're going to want to make sure on the AP exam on question number 1 that you address all 4 of these, shape, outlier, center, and spread, and you address all of them in context. Okay, you have to give context to the problem. It's okay to list shape, outlier, center, spread separately, just make sure that you include context in your description. Now the other thing beside the word describe is sometimes you will hear, or you will see on the AP exam, that they want you to compare two distributions. Now in that case, when you see the word compare, you're still going to go through your SOCs, shape, outlier, center, and spread, but you need to make sure that you are using comparative words. Okay, you don't want to simply list SOCs for each one of the distributions, you want to actually compare them. So to compare them, you need to use words such as greater than. The mean of the one distribution is greater than the mean of the other distribution, or less than, or equal to. So you need to make sure that you are using those comparative words when the question says to compare distributions. So let's go through each one of these 4 in detail here, starting with the shape. And as far as shapes go, I've got the 4 major shapes that you need to be familiar with. First of all, skewed left, which of course means that the distribution is pulled to the left, or that there are outliers on the left. So that's your skewed left distribution. Skewed right, on the other hand, is going to be pulled to the right, where your outliers are on the right-hand side. It's skewed right. Symmetric distributions are the ones that we dealt with for most of the year with our normal distributions and our t-distributions. And then I've added this other one here, the idea of bimodal. And bimodal just means that there are 2 modes. So there may be 2 bumps in the data. Okay, that would be considered bimodal. So as far as shapes go, those are generally the 4 shapes that you're going to have to be familiar with and be able to describe a distribution using. Now as far as center goes, there are 2 major measures of center, and those would be mean and median. Okay, I feel very comfortable at this point that we know how to find mean and median. As far as the spread goes, there are several measures of spread. Let me list a few of them here. One of those is standard deviation. Another one would be the IQR, the interquartile range, which is Q3 minus Q1. The range is a very simple measure of spread. And I'm not sure that I need to list it here, but the variance is a measure of spread, but of course it's related to the standard deviation. Okay, you just square the standard deviation to get your variance. Now the next thing we need to be able to decide is of these measures of center and of these measures of spread, we need to know which ones are resistant and which ones are non-resistant. And first we need to understand what those terms mean, resistant and non-resistant. And I think I'm going to start with non-resistant. If a measure is non-resistant, that means it will not resist changing when an outlier is present. In other words, if there is an outlier, it's going to have a big impact on that particular value. So we're going to say that for a non-resistant, our value would change a large amount in the presence of outliers. On the other hand, a resistant measure would not change very much. So we'll say would not change much when outliers present. So now that we have our definition of resistant and non-resistant, we need to go back to our measures and decide whether they are resistant or non-resistant. So let's start with the mean here. And we know that if there's an outlier present in a data set, that outlier is in fact going to pull the mean towards itself, whether it be an outlier on the top end or on the bottom end. And the mean will change significantly depending on the outlier. So in that case, we're going to say that the mean is non-resistant. It is not resistant to changing. Now on the other hand, the median, if there's an outlier, the median might change, but only slightly. The median is the middle value. If anything, it's going to bump up to the next value or bump down to the value below it, or it may not even change at all. So we say that the median is resistant. Now, as far as standard deviation goes, since standard deviation is generally a measure of spread, or the average distance away from the mean, if there's an outlier present, that is going to increase the standard deviation. So we say that the standard deviation is non-resistant. Now, as far as the IQR goes, if you think about the way the IQR is calculated, it is simply Q3 minus Q1. And Q3 is the median of the second half of the data, and Q1 is the median of the first half of the data. So really we're dealing with medians there. And so because medians are resistant, IQR is therefore resistant as well. Now, range is pretty easy. If you think about range max minus min, if you throw an outlier in there, it is definitely going to change. So our range is non-resistant. And then variance, I guess variance goes right along with standard deviation. And we're going to say that variance is non-resistant as well. So now that we've decided resistant and non-resistant measures, let's try and relate that to the shape of the distribution. Okay, specifically, let's think first about a symmetric distribution. And we deal with a lot of symmetric distributions in AP Stats, including normal distribution as well as the t-distribution. And if you think about the normal distributions that we've used, I generally have you label them with a capital N, followed by the mean and the standard deviation. So typically, anytime we have a symmetric distribution, we will use the mean as our measure of center, and we will use the standard deviation as our measure of spread. Now, on the other hand, if you have a skewed distribution, no longer do we want to use the mean and the standard deviation because those are non-resistant. And in a skewed distribution, very often we have outliers. So we would rather use the measures that are more resistant to the outliers. In this case, the median is resistant and the IQR is resistant. So that's what we'll use for the measures of center and spread for a skewed distribution. Now I've got a question here specifically about a skewed left distribution. And we know that if the distribution is skewed to the left, that there are outliers present on the left-hand side. And those outliers on the left-hand side are going to pull the mean down below the median. So we know for sure that the mean is going to be less than the median. And as far as our reason why, we're going to say because the outlier pulls the mean down. Now the last thing we need to cover here is the 5-number summary. It's been quite a while since we've talked about this, but the 5-number summary is the minimum, the Q1, the median, the Q3, and the maximum. And visually, the best way to show the 5-number summary, and we're used to this, is the box and whisker plot. So a box and whisker plot is showing you exactly the 5-number summary. And what it's really doing is splitting the data into quarters. That's why it's called the first quartile here at 25%. Then there's 25% between Q1 and the median, 25% between the median and Q3, and 25% between Q3 and the max. So visually, if we wanted to find the IQR is that box in the middle. Okay, it's the difference between Q3 and Q1. You can see that here. Now, as far as testing for outliers, let's suppose that you had a value way down here on the left, and you were trying to decide whether it was an outlier. Well, the rule is that you need to take Q1 and subtract 1.5 times the IQR. And that's your cutoff point. And if your value is less than that, it would be considered an outlier. So anything less than Q1 minus 1.5 IQR would be considered an outlier. On the other hand, let's say you had a value way up here on the right, and you wanted to decide if it was an outlier. Well, to check that one, you're going to go Q3 plus 1.5 IQR. And anything that is greater than that would be considered an outlier. So there's your rules for testing for an outlier. Okay, let's go ahead and flip to the next page. And I've got a quick calculator example. And there's a little bit of a story that goes with this calculator example. I'll try and tell it fairly quickly here. But at the beginning of my teaching career, I was in my second year teaching, we had a half day. And in the morning, we had students, and in the afternoon, the teachers were required to work. We had some work time. So the math teachers decided we were going to go to Taco Bell to eat some lunch. And somebody issued the taco challenge, which is the challenge to eat 10 Taco Bell tacos in less than a half hour. And there were only a few teachers that decided to do it, myself included. And I will tell you, it was very much a struggle, especially on that last taco. But I did, in fact, eat 10 tacos within the allotted time. And so the question that I want to ask you guys is, if I were to challenge you to a taco eating contest at Taco Bell, how many tacos would you be able to eat? Now, since I don't have a classroom here, I'm going to have to make these values up. And here's what I'd like you guys to do. We're going to put these numbers into a calculator. So have your calculators out. Let's clear out list 1. And let's just put some values in. Okay, and I'm just making these numbers up. Except for the first one, that's me, 10. Okay, not a made-up number. So let's suppose that students in the class gave the following numbers. 4, 5, 3, 8, 6, 5, 2, 5, 7, 6, 5, 9, 5. Okay, let's use that as our data set. So you need to put those into your calculator. And I'll tell you what the question would say on the AP exam. The question on the AP exam would say, describe the distribution. So hopefully at this point we know that when we see that word describe that we need to address SOX. And so let's hit each one of these: shape, outliers, center, and spread. And of course somewhere we have to make sure that we include the context of the problem. So if we start with the shape, the best thing to do is to go to your calculator and make a histogram. Now some of you would argue for the box and whisker plot, and actually either one of them is going to tell you something about the data. If we start with the box and whisker plot, or the modified box and whisker plot, that'll give us a good idea of the 5-number summary, and it will also let us know if we have any outliers. So I did that first, and I see that from the data set, we don't have any outliers that are present. So I can at least handle the outliers question. Now, sometimes you can tell the shape from a box plot, and sometimes you can't. A histogram will give you a much better idea of the shape of the distribution. So on your calculator, if you can go to a histogram and make that histogram, interesting. What I'm getting here is a distribution that looks like this. And if I had to describe the shape of that, I would say that there is a slight right skew to it. So I'm going to say, now I need some context here, so I'm going to start with that. The distribution of claimed tacos is, I'm going to say slightly, I'm going to use an ly word here, slightly skewed right. And you notice I got my context of the problem in there. Okay, be careful that you don't lose that context. We've addressed the outliers. We need to talk about the center. And we actually have two choices. We can use the mean or the median. But because the distribution is skewed, we would prefer to use the median here. So you can find the median by lining up your numbers and finding the middle number, but you can also find that median using the calculator. So just go to Stats, calculate, one variable statistics, and then scroll down. Now I'm getting a median of 5.5 tacos. Okay, in fact, it's interesting, if you look at the mean, my x bar value is 5.8, which of course is what we would predict. If we have a right skewed distribution, we would think that those outliers or those values on the right would pull the mean up, and you can see that the mean is greater than the median. Now, as far as what I would write down, I would probably just write down the median as my measure of center. And if we're using the median, that means for the spread, we ought to use the IQR. So you can also get that from one variable statistics. And my Q3 is a 7, and my Q1 is a 5. That's giving me an IQR of 2 tacos, which is really telling me the middle 50% of the data. Now, there's nothing else that kind of jumps out at me by looking at the graph. The other thing that you would want to check for is if possibly there are clusters of data with possibly a gap in between them. If there was clusters or a gap, you would want to make sure that you comment on that. Since I don't see that here in our distribution, I think I'm going to be comfortable being done with this problem at this point. Okay, so let's go to this last example. And in this last example, we've taken a random sample of students, and we've categorized them as either being juniors or seniors, and deciding whether they are in AP Calc, AP Psych, or AP Bio. And so we've got the data here. And the first thing I might do anytime I have a two-way table is to find some totals, row and column totals. So my row total here, I got 39 in AP Calc. I got 74 in Psych and 43 in Bio. Now for juniors, it looks like I've got 33 and 123 for seniors, which is giving me a grand total of 156. Okay, so we might need to have those totals. So I'm just going to clearly show that those are my totals there. All right, now this takes you back to your summer work again, but let's talk about what a marginal distribution is. Okay, if you see the words marginal distribution, you are going to be looking at row totals or column totals. Now, to decide whether you want row totals or column totals, you have to look at the wording of the question. So the wording of this question says, find the marginal distribution of classes among the students selected in the sample. Marginal distribution of classes. Okay, the classes that we have here are AP Calc, AP Psych, and AP Bio. So we are definitely looking for the column totals here, column totals and not the row totals. So we've got 39, 74, and 43. Now there will be times when they ask you for the marginal distribution as a percent, in which case you're going to have to take each one of those numbers and divide by the grand total. Okay, so if I took 39 out of 156, 74 out of 156, and 43 out of 156, that would give me my marginal distribution in percent. Pretty straightforward on the marginal distribution. Now the conditional distributions are a little bit trickier. So as a general rule for a conditional distribution, that means that you're going to be looking within one row or within one column. So how do you decide whether you're going to be within one row or within one column? You have to read the question, okay? And what you're looking for is the condition that is given. That's why it's called a conditional distribution. So if we read this problem, it says find the conditional distribution of grade in percents among students enrolled in AP Bio. Okay, the condition that is given here is among students enrolled in AP Bio. That means that I only care about the students in AP Bio. That is only this column. So you circle that column and you forget about the rest of the data in the table. Okay? So what do we have? We have 4 and we have 39. Those are our values in that column. But it does ask for it as a percent. So the question is whether we divide by 43 or we divide by 156. But because we were given the condition that it is among students in AP Bio, we only care about the students in AP Bio. That is the 43. And so we end up with 9.3% and 90.7%. Now, just to relate this to something that you're going to see later in Chapter 5 when we do probability, this 9.3% is in fact a probability. And if you look at the way that it's calculated, 4 out of 43, what that is, in fact, is the probability that a student is a junior, given that they take AP Bio. Okay, notice that that is a conditional probability, which uses a conditional distribution. So you will definitely see this stuff again when we get to Chapter 5 and we start to review some of our rules of probability. Okay, this concludes the Chapter 1 review. We'll get started on the Chapter 2 review in just a moment.